So today's session is about more pointers. We're still on pointers, arrays, and strings. Um, in the project requirements, we are only allowed to use VI, Vim, and Emacs. But for the purpose of these sessions to make things easier to understand, we're using the VS Code editor. And we're also going to compile the codes using the GCC command. And that's it for the rules. First of all, let's try to do some examples on how to print an array and how and show you different ways of looping through arrays, so everybody can understand very well how to use pointers and what pointers are for. Let's say we create a function, a main function, our main function, the default one, and we return is 0. This is the entry point of the program. And also I'm going to include the stdio library, so for us to display things on the terminal. Next, what are we going to do? We're going to create a function that displays an array. It displays the array, and the next function will be a function that displays an array in a reverse order. Then after that, we're going to see a function that displays a strings. And after that, we create another function that displays a string in reverse order. So these will be the 4 main things we're going to exercise on. Let's start with the function that displays an array of integer. I'm going to call it print int array. And the function receive as parameter an array or a pointer to an array. Great. There are different notations, but we're going to keep that notation much easier to read. So when you pass in an array of integer, we also have to specify the length of the array. So let's do that. Great. So when this function receives an array, it will loop through the array, then displays its contents or the values. We have different ways of doing that, but we're going to start with the simpler one. We declare a variable called index. For the index starting from 0, index lesser than the length, we increment the index. Then we use the printf function to display the value in the array at a specific index. Great. So that's it, how to display the content of an array. We're going to add spaces between the values displayed, and also we add a line break after the display. Now we are ready to call our print int array function. Let's call it in the main function. print. We're going to declare a test array, or I'm going to call it values. There is 10 value in this array, and we'll set it to 1. We're going to initialize the values directly here when declaring the array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have now 10 values. Always make sure the values that are you initialize the array with are not the numbers should not be greater than the size of the array, else the program might stop due to segmentation fault error. So we're going to display the array. We call it print int array. Then we pass in the array, and also we pass in the length. The length of the array is 10. That's good. Now let's compile the code and see. I'm going to open the terminal. Then we'll run the GCC command, GCC. Then the name of the main file, then the name of the output file. This will be main. So we have our executable created. Let's compile, let's run the executable. Oh, sorry. I'm going to change the terminal to git push. Yeah, great. So we're going to run the executable. So we see that the function displays 1, 2, 3. It displays the elements of the array. But now let's organize this code a bit. So here we're just going to have the calls to the functions, and the functions will be in their own files. So I'm going to create a main.h file and a file called print.int array. This file will contain the definition of our array function. So this will help us to organize the code a bit. So I'm going to copy the definition of the print array function and place it inside the print.int array here. And also the prototype, we're going to copy it and pass it in the main.h file. So we have to include the header file here. So include main.h file. And in the print in array function, oh, sorry, there is a typo here. We also have to include the stdio library because we're using the printf function. So the compiler needs to know about the printf function prototype and knows how to use it. So now the code is a bit more organized. We declared the array, an array of values, 10 values. Then we initialized the array. Then next, we displayed the array and with the function print.int array. So the same code, we can write it another way. Let's go in the print.int array function. You see that we use here the indexes but we can also use the dereferencing, because basically how an array is laid out. Uh, we have a set of addresses, memory locations, contiguous to each other, and we loop through these memory locations and displays the values. One ways of doing that is by using the index and the square bracket notation to access the values. But there is another way. For example, we can type in something like array, then plus index, and we use the dereferencing notation operator. So we're telling the computer or the compiler, take the address of the name of the array is the address of the first elements in the array. So when you type in something like array, that means the address of the first element. Then plus index will give you the address of the next elements. So if index is 2, that will give you the next element. Then we use the dereferencing operator to tell the compiler we have this address. Now we wish to know the value of that address. So using the start or the asterisk is the dereferencing notation. Now, let's create another function which, which displays an array in the reverse order. I'm going to create a new file and call it print in reverse. So the prototype of the function is void print in reverse. It will receive the same parameters as the previous one. This time we're going to change the notations a bit. So we're going to say int start array. That means a pointer. Then the length of the array. Now what we're doing here, we're going to start from back to start. How do we do that? Let's declare a variable called index is equal to length -1. I'm going to draw a bit for people to understand what is happening here. Just give me a second. I'm going to open the drawer tool. Yes, almost there. Microsoft. So turn the screen again. Okay. Can you see the screen? Now we have here, we have an array of 5 elements, and the index start from 0 to 4. The last element's index is always the size -1. So now what we want to do is to start displaying the content starting from back to start. So that's why in the code, what we did here is we initialize the index to the last index, so which is the length -1. So we can use a for loop for index greater than greater or equal to 0, we want the index to we want to decrease index minus minus. So we can now print the values, printf, then space, then we type in the array name, and after that we specify the index. Since we're using the printf function, we need to include the standard library, the stdio library, for the compiler to know what is the prototype of the printf function. Next, we display a line break at the end after we display the array. Great. So this is a function that displays an array in the reverse order. So we start from the last index, then we go, we start from the last index to the first index. So at each position, we display the elements at that position. Now we're going to test this function. Let's copy the prototype of the function and add it in the main.h file. And next, now now that we included the print in reversed prototype in the main.h file, we can use it in the main.c file, the program. I'm going to commence the call to this one. And let's call the function called print in reverse. We pass in the values, then the length is 10. Instead of displaying 1, 2, 3, 4, 5, 6, 7, 9, 10, it will now display from 10 to 1. Let's compile the code, gcc main.c, then the output file name will be main. We've got a problem here. The linker says that the print in reverse, he cannot find the print in reverse function. So we have also to specify the name of the file where the function definition reside. Let's run the gcc command again, gcc main.c, then the name of the file where the definitions of the print in reverse function reside. So print in reverse.c, then the output file, main. Great. So let's run the command. Let's execute the code again. So here, what you see is that we displayed, or we are printing the array in the reverse order. We started from the last index. We started from the last index here to the first index. In the first case, where we define the print array function, print into array function, we started from the first index, from 0 to the last index. So that's for integer arrays. Now let's try to do the same thing with strings. I'm going to comment the code here. Great. So it worked this almost the same ways for strings. Strings are no other things. They are just array of characters. Let's declare a strings. We can say str, this is our strings, and the string contain something like 10 character. And let's initialize the strings. So we have 10 char or 10 character in these strings. I'm going to name the characters A, B, C, D, E, F, G, K, L, M. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 character, but the last character should be a null character. So we have to make space for that. We'll have 11 character. So if we want to displace the alphabet from A to L, we'd have to create an array of 11 character. Then at the end, we have to specify the null character. So here, when you call a function to displace the strings, it will display the content of the array of character till it hits on the null character. So that's why the functions we're creating for the strings, we don't have to pass in the lengths of the array, because the end of any string or any string should end with a null character. Great. So let's create our function called print string. I'm going to create a new file, print strings. And the prototype will be void print string. And we pass in the string like that. A string is just an array of character. So how do we do that? I'm going to create declare a variable called index starting from 0. So for index is equal to 0 index. Here we don't have the length, so we cannot refer on the length, but this time we're going to change things a bit. We're going to say while the characters are at the index position is different than the null character, we can continue displaying the string. So we say print f. We're displaying the strings character by character. So we use print f, then the character format, then str indexed. Then after that, we're going to display a line break. So that's one way of displaying a strings, characters by character, but also we can display for the next function, we're going to display the same string in reverse order. For now, I'm going to include the stdio library because we're using the printf function. And let's include the prototype or add the prototype in the main.h file so we can test the function in our main.c file. Now we're in the main.c file. We're going to call the print string function. Then we pass in the string. And let's see what happens. GCC, then the name of the main file, and also the name of the file that contain the print string function definitions. With the O option, the output file will be main. Great. So let's run the executable file. Oh, we have a problem here because this is an infinite loop, which means that there is something wrong in the print string function. I'm going to stop it, the program. Yeah, here we said, wow, str index is different than the null character. We forgot to increment the index. So the index is not changing, then that's why the loop was continuing looping over again. So that was a bug. We're going to compile the code again, then execute. Yeah, so we have A, B, C, D, E, F, J, K, L. So the stop point is the null character. This is the most important thing to know, or the biggest difference between strings and an array of integer. An array of integer, there is no null character we specify there, but for a string, we have the null character that serve as a stop point. We are at the limit of the 40 minutes, so we're going to restart the session. Then we continue in the next function. You can reconnect using the same link.